We can just twist it up a little bit in the case that now we're analyzing graphs, and then we have to determine which inequality is going to best fit it. So in the other examples that we were given the inequalities, then we have to find the y-intercept. We need to get the slope, graph it, shade it. All that's already been done here though. Okay, so we don't need any of that. So the inequality is that we're going to be either using, let me just write them here, right? We're going to be using this less than or greater than, less than or equal to, greater than or equal to. As a recap, okay, this means that we're going to shade below for less than, right? And this is going to be a dotted line. This is a greater than, so we're going to be shading above, ABOVE, and this is also a dotted line. Okay, less than again, I notice that these are exactly the same here. Okay, these are the same, so we're going to be shading below, so it's the same in that regard, but this will have a solid line. And then this greater than here, both these guys here, both these greater thans are shade above, and we're going to have a solid line. Solid line is the way that I remember it is that we have this solid line underneath, and so they both result in a solid line. Okay. Also, another quick recap: a dotted line looks something like this. Is it dotted? Okay, and this is a solid line, SOLID. Also, anything that lies on a dotted line, not a solution. Not a solution. Okay, if it lands on a solid line, it is. It is a solution. All right, there's a lot of things. These are all things that we did in previous videos on class, and so you can just refer to that. All right, so this is still a straight line, so we're still going to follow the same format of y equals mx plus b. Now, it is important to note that we are not going to have an equal sign, okay, because it needs to be an inequality, so we're not going to have an equal sign at all. All right, so that's one important thing to note. So the easiest thing is, let's start with the y-intercept. Let me just write that down here. So this right here, I'll put a different color. This is our y-intercept. Okay, where it crosses the y-axis. Here's our y-axis. We're gonna just scroll down, 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 down. There's a -3. I'm sorry, -2. So this would be -3, -4. Looks like right there. That's where it's crossing the y-axis. Okay, since there's a plus sign here, right? There's really no need to write it. If I write plus minus, it's actually the same thing as just writing a minus. I'm gonna bring down this y, okay? Because these are things that I know are coming straight down. Like I know this x is coming straight down, right? And I'm just gonna rewrite this a little bit better. All right. Now the only thing is, what's our slope gonna be? Well, you gotta choose 2 points. Now don't just choose any random point. Don't choose a point like here. See how it's like not perfect? And what I define as perfect is something that falls right between the intersection of the grid. Okay, so we're gonna just go ahead and choose a good point. I'm gonna use this point here because it clearly intersects the y-axis perfectly. And I'm just gonna follow along, and you see right here how perfect that is. All right, now when you're dealing with slope, we're always gonna rise before we run, like in life. So we're going to rise 1, 2, 3, 4. So I'm rising, I'm going up, that's positive. And then we're going to run 1 over. So I know that my slope is going to be 4 over 1. Okay, now the next thing to look at, the final thing really is, well, we have a dotted line, okay, a dashed or a dotted, right? Dashed or dotted, so that falls under here, one of these two guys, all right? And notice that this graph is going up, okay? So if I'm putting my little man here, he's going up the staircase. So that means that this would all be below him. So that'd be a less than. So if we clean this up a little bit, this would be y is less than. Now 4 over 1, you can totally leave it like that, but I'm just going to write it as 4, since 4 divided by 1 is 4, 4x minus 3, and this will be the inequality that represents this graph, right? I think we should probably do a couple more examples like that. Let's see, which of the following points, which of the points are solutions? You remember what a solution was, right? Thinking about this. Solution? No. Solution? Yeah. Solution? Remember, if back here, if it's on a dotted line, not a solution. If it's on a solid line, it is a solution. So here we have a dotted line, so this is definitely not a solution. Okay, so let's go ahead and clear that out so we don't get too confused. And it says, which of the points are solutions on the inequality? Check all that applies. So you should actually pause this and try to figure this out and then check with the answers. So let's see, -3, comma 3. Look where that is, unshaded. This is definitely no. Okay, -2, -2. Yes, that's good. -1, 1. They try to trick you. That's not one. 0, comma 1. Perfect. This one's good. 2, comma 5. Yes. It is a solution. Even if you were to extend this, see how it's going past, right? All of this gets shaded in. So this is definitely, so it's just going to be -2, comma -2, 0, comma 1, and 2, comma 5. Now, in reality, these are all solutions, but just from what they gave us. All right.